Can everyone hear me at the back okay? Excellent, thank you. You're at the back, your job is also to call out on font sizes later, stand ready. Hello everyone, my name's Kris Jenkins, I work for Confluent, we're over there giving away free coffee. I am a developer advocate for Confluent, which essentially means I'm a colossal geek, but the kind of geek they let out in public occasionally. Going to have some fun geeky stuff today. One of the things they also let me do at Confluent is I host our podcast. I will be plugging that at the end if you've enjoyed the sound of my voice. And we were recording a podcast yesterday that was kind of about data mesh stuff. And one of the things I like about data mesh, one of the things that really resonates with me, is this idea of opening up your data, treating data as a product within departments. And if your data is a product that's as serious as everything else your department does, you publish it around the organization, you can open that data up in new ways. Every time you open data to a new use, you've doubled its value, I think. And what's the point of collecting all this big data if we don't have different ways of using it? The other thing that feeds into this talk is I used to be the CTO of a gold startup many years ago. And one thing I got really good at as a CTO, I think, is like managing these long-term projects. You know, the 6-month project that goes eventually to something big. A skill I lost as a CTO, I think, and I regretted it, and I worked hard to get it back, is the ability to knock something up quickly, to make a prototype, to build things quickly that test ideas. So that's something I'm going to do with you this morning. I'm going to build something that opens up some data, hopefully inspires you in a way to open up data in your organization. I'm going to try and teach you some things about Apache Kafka. I'm going to teach you some things about back-end programming. I'm going to teach you some things about front-end programming. It's going to be enormously geeky, and hopefully you'll just learn at least something you didn't know along the way, and we'll have some fun. This talk is unashamedly code-heavy. This is a man falling into many lines of code. I make no apologies for that. I like code. It's the language in which I speak. It's the language in which I make things happen. Hopefully that applies to a lot of you too. So let's enjoy it. So here we go. I have a terminal. Who's a programmer? Excellent, you're going to love this. Who's a non-programmer? Excellent, you're going to love it too for different reasons. It's going to be great. So, I want you to imagine, for the purposes of this, that I've got a business selling stuff. It might be selling gold, it might be selling something more every day, but I've set up a business. They are making trades all the time. People are buying stuff all the time. Hopefully it's a successful business. And so I'm either storing that data primarily in Kafka as my master database, or it's coming through from Postgres or Mongo or something else, streaming into Kafka. And I'm going to query it. Can everyone at the back see that font size? Yes, good, thank you. So let's do select star from purchases. And that's a standard SQL query that no one will be surprised by, I hope. One thing that's kind of interesting about Kafka is it behaves a lot like a database, but it also behaves a lot like a real-time stream of up-to-the-minute information. So not only can I select from the purchases we've got, but I can say emit changes, and we will watch that stream of purchases live as new things are sold. So this is a potentially infinite stream of our purchase history with new, admittedly dummy data coming through. Right. What I would like to do, presumably that's going to an orders warehouse and it's going to sales and accounting and all those good things. I'd like to open this up so that everyone in the company knows how much we're selling. I've run a startup. I've been in a position with a startup that's not selling anything. And when you finally start to sell products, it's a very exciting day. And I actually did this at our gold startup. I built a dashboard that people could see how much we're selling and made it accessible to everyone in the organization. And that really changed the way we focused on sales. So I'm going to show you a way to do that. So I've got this stream of data. First thing I'd like to do is kind of aggregate it into how much we've sold so far. So I'm going to say, let's create a new table. I will call it dashboard. and I am going to do it this way. I'm going to say, create that table as select sum of the price as the total so far from my purchases. It's an aggregate query, so I want to group by something. What shall I group by? Doesn't have a natural group by key, so I will create a dummy one. I'll just say sales, okay? So sales is my dummy group by column as category. And then I'm going to do, so that's going to create me a standing table which will summarize the dashboard. I'm going to do one other sneaky, oh, there we go. Right, shouldn't have done that. Typed it too quick. Drop table dash, 1 sec. I'm going to do one other thing I want to change about this. Come on. Ah, no, I don't want to update Slack. Right. One other thing I'm going to do, I'm going to add in an option, and you'll see why later. I'm going to say, with the underlying place where we store that data also being called dashboard. Otherwise, it's going to auto-generate a name that's going to be tricky. So let's do that. Create table dashboard. That will take a moment to run. Oh, no. Oh, right, this is going well already. Live coding, it's a tightrope war. Are you rooting for me? Yeah, thank you. Okay. Hang on. What I'm going to do is come out and go back in. It's all going to go well. Promise you. Let's try that. Okay, hang on. Pretend this is all just fine. Create table dashboard 2. Yeah, we're all programmers here, right? Thank you. Okay. Oh no. Okay, that's a serious. Okay. Backup idea. Backup idea. Always have a backup. Would you like to see our cloud product? Yeah, of course you would. Right, so Confluent, we run Kafka in the cloud. I'm going to log into this. I should have a dummy system running against the cloud if their Wi-Fi holds up. This is my backup position. So, come on, you can do it, you can do it. I'm going to work this from 2 angles. Let's see if that's woken up yet. Let's try. No. Let's try that one. Yes, okay. Right, we're back on track. It's all going very well. Right, so let me just check we've got that. Select star from dashboard 2. There we go, sales totals, right? And if I keep selecting from that, it's a table with 1 row that is the sales total so far. Nothing too special. I have worked at organizations where this will be the end of the project, right? And everyone's expected to know how to log in and do an SQL query. And if they can't, they don't have access to the data. Not great, but I have worked in that place. So it's a table. It looks a lot like a regular relational database table. Another thing that makes Kafka interesting is we can subscribe to this table, again with emit changes, and we can watch, and every time that total changes, we'll get a notification come through, right? So this is a 1-row table. It's still just 1 row, but every time that row changes, we get told. We're starting to open up our sales total as a real-time stream of information. Okay? At that point, we will leave Kafka and start doing some programming, some real programming. So, I'm going to do 2 things. I want a front end for this, and I want a back end web server for this. I'm going to start by saying yarn create react app in the client directory. The reason I'm doing that first is it takes ages, even on a good Wi-Fi connection. So I'm going to leave that running in the background. And now we're going to think about making a server. Okay? So I'm going to do this in Python. Any Python programmers? Oh, loads! Excellent. You can critique my Python as we go, right? So I am going to edit a file called server.py. And we will pull up. I'm not going to ask if there are any Emacs users. I assume you're all Emacs users, right? Of course you are. Yeah, love it. So I'm going to start off with a standard Python preamble. And I'm going to say, this is all, oh, that's weird. That's a weird font color. Let's not do that. Let's go, should we kick it old school? Let's do that. Is that readable? You happy with that at the back? No? Better? Yeah? I'll go a little bit larger. Yeah, okay. So this is all standard Python stuff that I will just type in. If the name of this function, if the name of this script when you call it is main, then run my main function. Oh, actually, let's just leave that out and say this, def main pass, okay? And then let me set up a virtual environment, because that's good practice for Python. And source there. Source env bin activate. Okay, so I'm going to want 3 libraries for this Python code. I'm going to want to connect to Kafka using the Confluent Kafka library, which, for obvious reasons. I think what I want to do is live streaming this data out. Kafka's really good at live streaming data as it happens, and I don't want to lose that property. So instead of building an HTTP server, I'm going to build a WebSocket server. So I'm going to install the WebSockets library. And because I'm dealing with the webbish world, I'm going to get in simple JSON as well for JSON processing. Let that come in. That worked faster than I expected on this Wi-Fi. Okay. Now, let's set up a basic WebSocket server. So the way that works, let's start by saying logging.basic config. The logging level will be logging.debug, let's say. And let's say logging.info start. Oh, no, don't put semicolons, it's not that language. Let's just see if that's going to work. Import. Do we like that? I think we're good. Chmod user plus execute server, and then okay, basic Python program. Everyone impressed? No one impressed? Okay, yeah. Getting anything to work is a miracle some days. Okay, so how do you build a WebSocket server in Python? It's complicated by the fact that to build a socket-based server, you kind of need threads, and Python doesn't really have threads. But it steals the same trick that JavaScript's been using lately, which is to do asynchronous callback wrapping stuff. So if I say something like this, my main function is an asynchronous main function, and you can call it by using the async.io library to kick it off. And then you can say asynchronous, yeah, let's do it this way. Let's say WebSockets.serve, and then you give it a function that's going to handle each new connection as it comes in, right? So I'm going to call that handle connection. You tell it which address you're going to bind to. I'll just use localhost, and which port. I'll use 8080, right? And then if I import WebSockets, and I've got to define this handle connection function. It's pretty simple. It's also an asynchronous function. It takes 2 arguments, the connection this new client has connected with, and a path if they want to specify a path on the URI, which I will ignore, but the contract says I have to accept 2 arguments, so just do that. And then I'll say pass for now, okay? Good. Let's see, oh, I need to import async.io as well. Let's see if that works. Let's put a clear in, stick it at the top. Not quite. Not terribly interesting. Why doesn't that work? The reason is we start the web server running and it says, okay, I've started and now I'm done, and the whole program stops. We need to do something to say, actually keep that WebSocket server open indefinitely for a long time while people connect and disconnect. There are a few ways to do that, but what we really want to do is say asynchronously, with this thing open, do something that takes ages, forever, holds open indefinitely. And the trick to doing that is with something called a future. If you don't know what a future is, it's very simple. It's like when you forget your wife's birthday, right? So you know what you do when you forget your wife's birthday? You go down to the recycling, you get an empty Amazon box and you tape it up and you say, "Happy birthday, darling, don't open this till later." And then you've got 12 hours to find her a present and get it inside the box before she's allowed to open it. That's what a future is. So if we give this WebSocket server a box that it's not allowed to open and just never fill that box, then it will hold open indefinitely. And the syntax of that is to say, await this future, which we will never fill. Okay? I'll import that from async.io futures. And if I do that, now it holds open indefinitely. Good start. Let's try connecting a client to it. So, WebSocket programming tip, you know Telnet, curl, ping, all those useful tools? There's one called WS, and if you're doing anything with WebSockets, download it. It's terribly useful. It's your kind of go-to WebSocket client. If we do that, okay, so it's opening, but it's closing. Same problem. We kind of want to hold the connection open indefinitely, but it's closing instantly. So what we can do is go over here and say something like, let's send a friendly message. Await connection.send. Hello, Big Data London. Typing skills. And then we need to hold that open and wait. There is a thing here which is very useful for these connections. We can say connection.wait closed. Wait until the client closes and then I'm allowed to close, right? So if we do that and we restart this, and then if I connect with this, hello Big Data London, and it stays open, right? I'll just do one more. Yeah, so that is, in a handful of lines of code, a basic WebSocket Python server. It doesn't do anything terribly interesting yet, but let's get to that. What's the interesting thing we want to do with it? We're going to need to go and connect to Kafka and get that dashboard data through. As I write this, someone please remind me that the dashboard is called dashboard 2, if that comes up. So, I'm going to define a function that will connect to Kafka with a read-only connection. And in Kafka parlance, a read-only connection is called a consumer. It consumes stuff from Kafka and reads through it. For that, we're going to need to create a consumer, which I'll fill in a minute. We're going to need to go into some kind of loop, which I'll fill in a minute. And then, we're going to need to get that consumer to, I'll fill this in. The consumer subscribes to the sources it's interested in. And there's only one, and it is called dashboard 2. I remembered. Hooray. Then we'll go into some kind of loop, and we'll say, hey, are there any new messages? Has anything happened since the last time I looked for data? So we'll do that every 200 milliseconds, something like that. We'll do something with the message. And when we're finally done, we will say, I should stick a try in there, because we've got to be good people and say consumer.close at the end. Something like that. So let's fill in the holes. That's the pseudocode. Let's fill in the holes. Which one should we take first? Let's just do logging.info got that message. That'll take care of that for now. Let's have a look at this while thing. So I could go into an infinite loop, a bit clumsy. What I'd really like to do is shut down the consumer whenever I press Control-C and shut down the WebSocket server. Right? I'd like to have some way of signaling to the consumer it's time to shut down now. So I'm going to create a shutdown flag. And as good a thing to use as any is another empty box which I can fill. If I give it a future, and then I say try this, and when you're finally done, here's a box you can fill. You can say, hey, take this shutdown flag and set the result to, it's just a flag so it doesn't matter what the value is, set it to true, that'll do. And then, if I've got that and I pass it to my consumer here, I can say, as long as this is not done, we can keep going. So that's how I'm going to hold the consumer out open until it's time to shut down. Okay, that should do that bit. Shall we create a consumer? There are a couple of consumer choices in the Python library. The one I want is a deserial, this is a really hard word to type when you're speaking, deserializing consumer, and that's going to take a config. And that config will be some object, which I'll fill in a second, right? The config object takes 3 properties that I'm interested in. You need to tell it the bootstrap servers. Config objects to any database, a little bit dull, we'll race through it and you'll at least know how to do it if you want to do it yourself. So bootstrap servers is where can I find Kafka, where should I start looking for it? And I am running it on localhost 1992 because I was going to run it in the cloud, but I don't trust the Wi-Fi here. Sorry, folks. So that's a good start. Let's stick in a comma, I'll get better auto-formatting. The next thing you need to do, this is an interesting feature of Kafka, it has a really good system for work sharing. So you can just connect one person to the database and it will be absolutely fine. But if you wanted to say, we've got a lot of work to get through, I'd like to connect 5 people to this same database, 5 processes, and share the work across them so they can do it 5 times faster. And I want each message to end up at one of those 5 and only one of those 5. I'm not actually going to use that feature, but it's really useful and worth talking about and worth knowing about. And all you do for that is you say, I'm in a group, and all the processes that have the same group ID will work share pretty much transparently. So for this, you have to specify it. It's a group of 1. I'm just going to say dashboard demo. That'll be fine. And the other thing I need to do is I've got these bytes coming across from Kafka. I've got to teach Python how to turn that into a Python object. So I'm going to need to specify my value deserializer. Yeah, I don't like typing deserializer. I'm going to specify that out somewhere around here. I can do that separately. Okay? So that, if I can get some imports going, import Confluent, Kafka, and I think I'll get the schema registry while we're here, which I'll talk about in a second, and Avro, and then I should be able to import that. The crowd divides now between, people who hands up if you thought Emacs had autocomplete. How hands up have you never thought? Don't put your hands up. You never thought about it, did you? You never thought about Emacs having autocomplete. It does, I promise you. I'm an Emacs nerd. What can I tell you? Okay, so we're getting close. This looks like it might be sensible. Value deserializing, right? So a thing in Kafka is you can just store raw bytes if you want to, or you can structure your data pretty much however you like if it's raw bytes. Or you can say, I'm going to specify a schema that we want people to adhere to. And I like to do that. I think it's a good idea. Schemas enable reuse of data by people you haven't spoken to. So what I've done, my data has an Avro schema. You can choose Avro, you can choose JSON schema, you can choose Google Protocol buffs. And I would advise you to choose the one you're already using, and if you're not already using one, use Avro. So I'm going to use an Avro deserializer, which is another Apache project, deserializer. And that takes a very simple configuration object. It needs to know where can I find descriptions of the schemas. It needs to know where can I find a central repository that describes all the data, a schema registry. So I'm going to give it a schema registry client, which I will define here with a schema registry client, and that takes quite a simple configuration object, which is just a URL, which I believe will be on HTTP localhost 8081. I really hope I've got that right. Let me put in another comma. There we go. If I import these, we might actually get some code running. Should we try that? Who wants to try it? Everyone wants to try it. Thank you for joining me. Okay, let's kill these off for now. And we'll run that. Not terribly promising yet. We're almost there, I promise you. So the thing I have missed out is I haven't actually set that function running yet. How do you get a background process running in a language that doesn't really have threads? Joy of Python. So what I need to do is say, I want you to run this consumer with that shutdown flag as your argument. But if I do that, the whole thing is going to block and the WebSocket server will never start up. I have to kind of persuade Python to kind of run this in a pseudo separate thread, separate process thing. I can do that by saying to the async.io library, get the event loop, and then from there, call run in executor, and this function will allow me to create like a separate spawned off thread. The first argument is the thread pool. 5 minutes! Oh, crikey, no one told me. I thought I had 40 in total. Okay, let's move fast. So I run my consumer, and the thing I need to do with that consumer is give it the shutdown flag as a separate argument. Wow, I have less time than I thought. I apologize for that. The source code will be available online. Okay, now we're getting somewhere. This is running the thread in the background. Let's just do a quick thing. So you can see most of these messages are none, and some of them are kind of objecty object. So the message you'll get back from Kafka, it might be none. So if message is none, then we'll just say, let's say logging.debug waiting. We'll do that. It might be that the message is an error, and if it is, I'll just error that out. So message.error, like that. Oh, that's not going to work. There we go. Otherwise, it's an actually useful message. So I can say, hey, payload is message.value, and then I can say logging.info. Send S that payload, and let's have a look at that. Okay, so if I restart that, getting closer, okay, racing through this for speed. So what I would, so I will also need to turn that into JSON, simple JSON, dump that to a string, do it like that, and we'll get rid of that decimal thing, and instead import it. We do that. Okay, so now we've got a JSON packet, WebSocket server. Last thing with my remaining 3 minutes, I'm sorry I'm going to have to skip over, but you'll see enough to make a useful project out of this. So I would like to say WebSockets.broadcast that to all connected clients, that payload, right? This is a nice thing that Python lets you do. You can broadcast very easily to all the connected WebSocket clients. For that, I'm going to need to pass those clients around. So I'll get that from here. I'll pass it into here. If I stick a comma in there. And if I say client is a new set, then I can start passing my clients around. If I can pass it in, I'll teach you one more thing. So what I'd like to do is I'd like to say handle connection clients, right? Pass that set of new clients around, and in here I say clients.add this new connection, and after they close I'd like to remove it, and I get it in there. Hang on. So I could almost do that, right, and then that would work, except I've just broken the API for handle connection because it's expecting a 2-argument function, and what I'm doing here is some weird thing where I'm giving it a 3-argument function, 1 argument, and hoping it's going to pretend like the next 2 are coming. That would work in Haskell. If there are any Haskell programmers in the room, there probably aren't, but I love you. In Python, there's a trick to doing that. You can say, use the function partial, give it the function you want to deal with, and the first argument, and it will return a function that's expecting the rest. So this is kind of related to closures in JavaScript, if you're familiar with that. So if I do that, and I kill that, and I restart it, and now I can connect. Now I can connect this client, and it's getting JSON through, and I can connect another client, and that's getting JSON through, right? So data streaming out of Kafka in real time through a WebSocket server that we can then broadcast to a front-end client. And if I had 10 more minutes, I would build you a quick React app to show that, but I'm out of time. Thank you very much for listening. I hope you've enjoyed that. If you want the full source code, including the React part, you'll find it under that link. If you're not tired of my voice and want a link to the podcast, you'll find us there. If you want to see more Python coding, I have a video coming up on YouTube, I think at 5 o'clock this evening. You'll find a link to that there. I built something much more ambitious in a pre-recorded format. I'll be on the live Q&A. I'm here all day over at the Confluent booth. Thank you very much.